Hi, in this video I want to share a quick story about the dummy battery which I bought. How I tested it, what was inside the casing, explain it on a schematic, and why I decided not to use it in my camera. But first, what is a dummy battery? Let's connect it to the camera. Remove the normal battery. Insert dummy battery. And the other end of the cable, where the USB-C connector is, insert it to the wall charger. Now, power for the camera comes from the wall socket and you don't need to swap batteries. The camera model is Panasonic Lumix G7. As you can see, 8.4 volts is noted here as an input voltage. The model of the dummy battery is DMW DCC8. And as noted here on the sticker, the output voltage should be 8.4 volts. Let's start testing. Quick and easy test is to measure the output voltage of the device. For this, let's connect it to USB-C charger. The charger is also indicating output power here, which is of course 0 right now because it's not connected to a camera. Next, let's put our multimeter to voltage measurement mode, DC voltage, and connect the probes to the battery outputs, which are marked on the case as plus and minus. And we see voltage of 9.15 volts, which is clearly higher than the promised 8.4 volts on the sticker. Although it seems to be odd to have such a high voltage on the output, I decided to connect electronic load to the outputs and then measure the voltage again. This way we are kind of emulating what would happen when the camera is connected, because with some power supplies the output voltage can drop quite a bit when some load is connected. This is the electronic load. Here you can see the current. For example, right now it is 0.4 amps, and we can adjust it with this knob. These are the probes, and I have also connected my multimeter in voltage mode so we can actually see the output voltage accurately. Now we connect the electronic load to the battery output. On multimeter we can see that the voltage is still 9.15 volts. This is because the load hasn't been activated. Let's turn it on. For example, with 0.5 amps, the voltage is still high actually, over 9 volts. Let's increase the amperage. For example, with 1 amp, voltage is still high, about 9 volts. Let's increase it even more up to 2 amps, which is in the device's spec. Still the voltage is high, 8.86 volts. The maximum voltage what the camera battery can have is 8.4 volts. The maximum voltage seen with this dummy battery was 9.15 volts, which is quite a bit higher. This was concerning for me, and I started searching internet to see what other people have experienced. Some were saying that it is totally fine to use a bit higher voltage on similar cameras. Some were saying that it could be dangerous and could damage the camera over time. So I decided to not take the risk and I will not use it. Still, I wanted to know, how does this device work? What is inside the casing? Is there really a DC-DC converter? So let's take it apart and find out. First, I will show you how to disassemble it incorrectly. I thought that here, where the two case halves are joined, this is done by welding. Of course, I used the cutters to cut open one side, then the other side, and now it was possible to just pull it apart. Now later I discovered that under the sticker there were 4 screws hidden. If you remove these, you can open it more safely. And of course, there is no DC-DC converter inside, just this. As we saw, there are only wires, contacts and a resistor inside the casing. So I started to have a feeling that maybe the power wires are just going from the input to the output, and there is only a chip to request a certain voltage from the USB charger. To be more certain of it, let's measure the resistance between the input and output. To get access to the very small pins inside the USB-C terminal, we are actually using this little converter. And now we have access to the ground and the voltage supply. We put our multimeter to resistance mode. Now we measure resistance between the input and output. First, let's check the ground pins. 0 ohms. Let's switch the probes just to be sure. And of course 0 ohms. Let's check also the positive voltage side. 0 ohms. The other way around. Again 0 ohms. Just to be sure, let's also use the diode mode on voltmeter. Will we see, for example, any junctions or any voltage drop? First, ground pins, nothing. The other way around, again 0. Let's check positive side, 0. And let's reverse the probes, again 0. So for me, it seems that actually we have direct connection between the input and output. This is how the schematic probably looks like. Battery case, 4 connections to the camera, plus for positive side, minus for negative side, and T to check that a healthy battery is inserted to the camera. There is 10 kilo ohm resistor in this dummy battery. It is connected between the negative side and the T pin. So the camera can measure this resistor, and probably if it finds out that it is 10 kilo ohms, it means that battery temperature is good, we can use it. Cable from battery case to USB-C connector. This connector is going to the USB charger. Inside of it, probably there is a chip which is just requesting certain voltage from the USB charger. And then there are wires going directly from USB-C connector input to battery output. Because as we measured from here to here, the resistance was about 0 ohms. Also in diode mode, we just saw the 0 value. So basically the chip is requesting 9 volts from the charger, and the accuracy of the voltage is just depending on the charger output, which is then going to the dummy battery output and into the camera. So in the end, I will not use it with my camera, but it was still super interesting to know how does it function. Because clearly the people who designed it, they knew that it will not deliver the voltage which was written here in the spec, but with super low budget, they tried to create something anyways. If you enjoyed the video and want to support the channel, please hit the like and subscribe. Thanks for watching.